Well, it originated, of course, from Newtonian physics for the two-body problem, where the force between the two bodies is proportional to the product of the masses and inversely proportional to the square of the distance between them. And that was a metaphor that was then taken to various economic interactions where it seemed like a reasonable sort of thing to say, well, there's a mass, maybe the size of the market or the number of people at the origin and the destination, and then there's a distance between them, and then we realize there might be some other things as well as just purely physical distance that also affect this flow, but also in a kind of inversely proportional way. There's a sort of friction which limits it. And so it turns out that just using that metaphor and lining it up with data, it actually works incredibly well for all kinds of interactions. Migration, where there's the size of the population and the city of origin and the city of destination and distance between them. For goods, which actually came a bit later in terms of the historical applications of this sort of thing, and then the flow of capital between origin and destination. So all of these sorts of things were telling us this is a really important empirical relationship. But there was actually always something a bit puzzling about it in terms of economics, because you'd say, well, sure, that's a good insight. I mean, we do know there's economic interaction, and we know now it's empirically, somewhat. It's actually not more than so much. It's very extremely robustly connected in this way. So the problem was, though, that we know that, as in actually Newtonian physics, the two-body problem is a very, very simple special case. And if there's a third body somewhere nearby that's massive enough, it's certainly going to influence the trade between those two bodies. And at this point, the analogy with physics really breaks down, because what's known about the multiple body problem in physics gives you some very different kinds of structures. But for economics, we're sort of left with this puzzle. Well, we got this metaphor that we started with. It works well, but there's a problem with it because third party interactions are not somehow influencing that bilateral interaction. And so that was the starting point, actually, of my research in this, where I figured out a way to introduce the third party, et cetera, interactions, which has to do with, first of all, thinking, well, once you have a many by many flows and you're trying to solve for that, you realize, well, the attractiveness force in a particular bilateral is, of course, relative to the attractive force going to all the other possible pairs. And so this is solved in economic terms with a very simple kind of idea about, profit maximizing behavior by people that are trying to take advantage of price differences is going to do what we call arbitrage. And so spatial arbitrage is going to actually very strongly modify what just some raw forces might be if you forget about the third party interaction. So that was actually then boiled down into, it turns out, you can think of the multilateral part of this as there's two parts. So one is on the seller's part. The seller can sell into a particular market, but also into all these other possible third markets. And it turns out it was possible to sort of summarize that into effectively a two-body problem again, because you could say, well, there's the market I'm focused on, how much I sell there, and then there's a kind of average of all the other frictions that I face trying to reach all the other markets. And so that's outward multilateral resistance. And then on the buyer side, well, the same thing. The attractiveness of buying from some particular origin is relative to, well, I could buy, similar, not exactly the same, but similar goods from all those other possible origins. And so again, that's all captured in it. Now it's called inward multilateral resistance, and it's how hard it is to buy from all those other sources. And the balance of those two things is what actually enters into what the equilibrium is when the arbitrageurs, the people who are actually sort of doing all this calculation of how I can make money by switching a unit from partner one to partner two, all of that stuff in equilibrium says there's no more profit to be made from any moving around. And so in the equilibrium, you then get this sort of nice insight, which says that the bilateral resistance, which is what we started with originally with this sort of simple idea, now we can bring in the multilateral resistances, and it turns out it's actually a product. So it's the bilateral resistance relative to the product of the inward and outward multilateral resistances that conditions how much you actually see bilaterally in the real world. And so then taking that model to data then gives us a model that's economically satisfactory. And it turns out to have some important practical consequences too, of course, as you might well imagine. After some years and years of people sort of using this for various kinds of flows, we had this famous border puzzle posed by a famous paper by John McCallum. He was able to take advantage of very good data on the trade of Canadian provinces and where they went. So they would go to other provinces, but they also went to American states. And so this data was like very good quality data for reasons that have to do with how come they wanted to keep track of all this stuff inside Canada. And so he then realized, well, I can take out distance by getting trade between a province and another province, and that same province and another American state that's the same distance away, basically. And so I'm now taking out all the huge effects, obviously, of distance. And what's left over, well, that's a border effect. That's saying that just crossing that border. And I don't know what he actually expected when he did this, but what he found was borders have a huge effect, which was like really, really puzzling because, very, very similar countries in a lot of ways. The language is common, the legal origins are common, and they are neighbors and they understand a lot about each other. And so, well, why should we be getting this big, big border effect? And then the origin of the paper we're talking about was that a subsequent working paper that I saw by Eric Van Wynkoop actually had using the same kind of gravity model that McCallum did, which was not accounting for multilateral resistance. And so what he saw was from that if you did the same thing with the reverse flow, American states to Canadian provinces, and so now we're getting the reverse flow effect. Well, the border effect was way, way, way smaller, like an order of magnitude smaller, 10 times smaller. And so this was like a huge additional puzzle. And then I realized that at that point that I could maybe combine with Eric and we could tackle this problem appropriately using this idea that, well, they have these multilateral resistances that we are running around in there. And so that the paper in question figured out a way to actually calculate what those multilateral resistances are, which essentially they are a trade weighted average of all the bilateral frictions, where the trade weights are, of course, endogenous to the equilibrium. They're being determined simultaneously with the whole equilibrium. So you actually had something that was a very important endogenous variable. These multilateral resistances had to be all worked out simultaneously in a way that was consistent with economic theory and put the kind of econometric practice that we could use. And so we figured out a way to do that. And what that did was, in a sense, resolve the border puzzle. And so the resolution of the border puzzle involves a key insight, which is after the fact, you sort of look at it and you say, well, gee, that's really obvious. So another regularity in the data, also long known, is that larger economic entities trade more in their local markets than they do markets further away. And so that's another very strong regularity. So you would say, well, now let's take the entities of the United States and Canada. The United States is an order of magnitude bigger than Canada. And so that means that the US states naturally are trading a lot more with other US states. That is the case with Canadian provinces trading with other Canadian provinces. And so once you see that way, you say, well, the multilateral resistance that Canadians face on their international interactions is going to be way bigger because they inevitably have to do more of their trade outside of Canada over longer distances and crossing borders. And so the multilateral resistances are given a kind of very natural explanation for why they're so different between Canada and the United States. And so what had been the puzzling border effect was really just the effect of the relative size of countries on the multilateral resistances. And so we now had a kind of understanding of why the multilateral resistances, quite naturally have to differ quite a bit. And so this was because the puzzle itself was considered so interesting, and there was always this feeling, well, gee, I mean, gravity works really well empirically, but we just don't understand why, And so now we've got all of that kind of wrapped together in a nice sort of understanding that deepens really our understanding of how the world works. Obviously, tariffs are explicitly taxes posed at the border. There are various other kinds of rules and so on that influence that, and including the fact that border officials may be doing things unfairly in a way, favoring some kinds of transactions over others. And of course, there are differences that are less maybe susceptible to policymakers actively, trying to do anything, which nevertheless, maybe over more time, you could think more about, well, harmonizing your regulations so it's easier to, sort of keep track of, the phytosanitary regulations and so forth. You write the rules in a way that everybody says, okay, well, we're all going to keep track of things just that way. So then you can sort of see whether you've improved trade just because of simplifying that stuff. So there's a lot of stuff that's maybe susceptible that isn't just a tax, but sort of acts like a tax. And then there's other stuff that probably you can't do much about. Whether you have a common language or not. The common legal origins of laws, and so it's just harder for businessmen to figure out if the laws are different. And so those things are much less susceptible. And then what's left over, it's actually been really once we really understood better how to do this, it's been quite an interesting journey into again, in a sense, posing second order puzzles that are super interesting. Like historically, one of the things that struck me was the German Länder that were part of the Zollverein of the 19th century, which precedes the creation of Imperial Germany. That those Länder or provinces or whatever they were, like originally they actually, all else equal, they trade more with each other than those which were not mutually part of the Zollverein. So there's a lot of other historical things that sort of look like that, saying, boy, there's this incredible persistence that shows up in the data after you do your best to control for everything else. Well, that thing is still there. So we've found pondering the border puzzle, quite fruitful, and it's had effects on thinking about things like Brexit. Like Brexit looked incredibly foolish from the point of view of gravity. The idea that you're going to make up by doing trade deals with North America what you're losing by getting out of the EU, when roughly speaking, North America is 10 times further away than is the EU. I mean, this is obviously a dramatic example, but less dramatic examples would be Scotland's thinking of exit and or Catalonia thinking of exit, and I guess other things that are maybe forces for dissolution within the EU. So these are, and of course, it's less serious in the case of the United States. I mean, the Civil War seems to have settled whether you can have secession or not, but it still comes up once in a while as this kind of pie in the sky type talk. But so understanding all this stuff about border effects, has interesting ramifications for lots of other phenomena. Using demand structure to say, well, there's an object that's easy to measure, which was your expenditure share, which would be what you spend on the goods you're importing or buying from home, divided by total expenditure. So that share, that budget share, is something to model as sensitive to price, and the price that the buyer has to pay is going to have embodied in it all this sort of stuff with resistance to trade. So by writing a pretty simple restrictive kind of demand system, we were able to get an expression which says in equilibrium, what you should see in equilibrium would be that the share that you can observe would be proportional to, well, the size of the origin country that's coming in there, and then a second term which is decreasing in the relative resistance, which is the bilateral resistance divided by the product of inward and outward multilateral resistance. That turns out to be the equation. And so we can then, fit that equation to data. And along with that, there are equations for what the multilateral resistances are, because the multilateral resistances are, well, for the inward one, it's the shares that you already got. Those shares, which are of course moving around, but in equilibrium, settle down into this relative resistance form. Those shares times the friction, the bilateral friction from all the places that you're buying, that turns out to be the outward multilateral resistance. And so it's something which is endogenous to the equilibrium. So you have to, estimate things, but you do it all kind of simultaneously. And so there's again on the seller side, of course, there's an adding up condition that says, my total sales have to get distributed everywhere. And so that gives you another sort of linear equation with shares in it, which you are then able to manipulate in just the same way and estimate. And so our original Gravity with Gravitas paper did that. And so doing it in that kind of complicated way was useful at the time anyway, in emphasizing to everyone that, look, this is all like there's a simultaneous equilibrium here involving all these pairwise relationships, but boiled down into things that we can actually handle pretty easily. It turns out that once that was well understood, then that's an unnecessarily cumbersome way of trying to estimate the whole thing. But that's another story. The puzzle was that if you did this sort of gravity structure naively, where you just think about the border without worrying about the pieces of the border that our model lets you deal with, what you find is that borders matter enormously more to smaller countries than to bigger countries. I mean, that was the original sort of issue posed by McCallum, and then the subsequent work where we're sort of looking at the states, trading with other states versus the provinces. So the understanding that we had once we, sort of get the results and think about it, the understanding that we had was, well, of course, outward multilateral resistance is this sort of trade weighted average of all of the frictions involved in selling every place else. Well, your domestic frictions are there, of course. Distribution, is costly everywhere, but your domestic frictions are systematically lower than the frictions to go long distances and also to cross borders. So all of that stuff gets put into this index that is an index, a number, so the weights that sum to 1 times all of those frictions. Well, a very powerful regularity then is, well, local markets are cheaper to serve. There's less friction there. So local markets, the bigger they are, the bigger the share they're going to have, and that's the lowest friction. So you've got the biggest weight on the lowest friction. So big countries are going to have smaller multilateral resistances than our small countries, and that's just sort of built in to what it means to be big or small. So getting this sort of right solution says, well, what you really want to do to really understand the structure of trade is you want to take out that effect of those multilateral. I mean, they're really important and interesting objects in themselves, but to sort of properly understand what's determining trade, you want to be controlling for that. Roughly speaking, the Canadian border going out is an enormously much bigger thing than the border for the U.S. crossing back in. And so, well, it's the same border, so that can't be right. There's got to be something just really, really wrong with that when it's an order of magnitude different. And now we get through multilateral resistance where you say, well, yeah, there's a very good economic reason for exactly why that part is true. What happened, well, to some extent around the same time, and then subsequently, you can apply, we applied it to trade flows. But you could apply the model to migration, which actually historically had been done back in the 1880s. And then the modeling that is done there often, although not necessarily 100% necessary to do it that way, but often the modeling there was done with the equivalent of shares. They sum to one, they're all positive. The share is like probabilities. And so probabilities are useful in thinking about discrete choice. Like people have different choices and different people make different decisions, and we can say, well, from the point of view of the econometrician, people that are otherwise equal, some of them make one decision, some make another. So this is the discrete choice. Like you get a probability that a person that is drawn from this distribution of people that you've controlled for all the things that would make them different. You say, well, okay, the rest of the heterogeneity is just because of stuff you can't observe that you think is random. And so discrete choice means that you have there are these extreme value distributions that are used to describe those probabilities, and then we can fit those. And so we get a model which actually has exactly the same kind of structure, that there's inward and outward multilateral resistance, there's the bilateral resistance, and that's all sort of built into a model that can fit the data very well. And so that's used for migration. It's used for, at least not portfolio capital, but foreign direct investment, that kind of, specific capital. So that's successfully treated with that same model. And the use of this, which I've seen some people use, of course I get papers where people are doing this stuff. I mean, it's very tempting to use this for the flow of ideas, and other sorts of cultural interactions and so forth. And again, the gravity model works, but it's not exactly clear how all of those things can be fit into this framework. And so there's people that, not me, I haven't actually gotten more than just kind of interested, but other people are I'm sure working on it, because it's kind of amazing how ubiquitous this gravity model of human interaction really is. And I mean, it must have some limits where, yeah, it's a complete bust. I'd be surprised if it doesn't, but it works pretty darn well for all kinds of interactions. One of my examples is, I interact more with the people that are on my side of the building. We have one floor, the economics department, a big building, and so I interact more with the people on my side than on the other side. All else equal, well, distance, even though it's maybe a 2-minute walk across the building. So it just works, it's a very strong thing. And it's tempting to think that, well, okay, maybe some of these insights here could be useful somewhere else too.